old microphone because Hogan turned it off. Okay, I got a little question over here. Isn't 1/3 equal to 2/6? Isn't that a true statement? Okay, so watch here. I'm going to flip this side. So therefore, because I flipped that side, what do you think I need to do over here to keep it equal? It needs to be 6 over 2. Are those still equal to each other? Is 3 over 1 still equal to 6 over 2? Right? Therefore, if I flip the one side, I can flip the other side. Now you might be asking, why am I doing that? It's because I have a y in my denominator. Okay? If I go ahead and flip them, this is now 1 over x minus 1 equals y minus 1. Do you see how I did that? Yes, no. You good? Okay. With that being said, what do you guys think I'm going to do at the last but not least? Add the 1. So notice, f of n's inverse is, instead of an x, we're going to put it back in n. Is that okay? 1 over n minus 1 minus 1, or plus 1. Isn't that exactly the same function it was originally? Can that happen? Pretty easy, just had to know that one thing. Anybody have a question here? Okay, so we are now, let's go ahead and I'm going to show you something today. It's basically the bottom part. So let's start with this guy. F of x equals the square root of x minus 3 plus 4. Okay? My goal is for you to find its inverse. Okay? How would we find its inverse? First off, instead of that f of x, kind of think about it as a y, correct? So what are we going to do? Once again, the definition is flip the x's and y's around, right, basically. So x equals the square root of y minus 3 plus 4. Anybody have a question on how I got that? Okay. First step, once again, this is the inverse already, correct? This is an inverse. But it's not what we like to see as a finalized answer. We like to manipulate this to solve for y because it feels a little bit better for us, doesn't it? Okay, so what's our goal? Anybody give me a hint? What are we going to do? Mike. Can't do that yet, though. After we subtract the 4 we do. So we're at x minus 4 equals the square root of y minus 3. If you have a question where I'm at on this, make sure, guys, you are paying attention to this and not your homework. We'll give you plenty of time to do it. Okay? What do we do now? How do we get rid of a square root? Go ahead, Rich. Use parentheses and what we're going to do to it? You know? Square it, right? What if I had a 5th root? What are we going to raise it to? The 5th power. If it's a 100th root, you're going to raise it to the 100th power, right? Everybody there with me on that? Okay, so I'm going to square it. So therefore, I am at x minus 4 squared equals y minus 3. Last but not least, Natty, what are we going to do? Huh? Solve, yep. I could do that. I don't really need to. Just want to get y by itself. How do I get rid of that? Yeah. I'm okay with leaving him right here. So therefore, y, or we could call him s inverse of x. And that's what you actually need to put, saying that this is its inverse, is x minus 4 squared plus 3. And that would be his inverse. So those are kind of like those backside 6. Is there 6 problems, I think, on the very top? Right? Okay? That's how you would do those 6 type of problems. Now, you might have done that through what Miss Lee's already showed you. How many of you guys felt okay with the inverses? Yes, sir? You felt okay? Does this make sense of what you do for an inverse? Okay. Now, the bottom half she didn't get to, because there wasn't a lot of time. Did you guys have a lot of time? Or did it pretty much almost go to the bell? Basically almost went up to the bell, didn't it? And that's how I do it, because when I taught mine, it was basically the same kind of feeling. So that's why I stopped it there on the inverses. Okay? So the bottom half asks you, are these 2 functions inverses of each other? Isn't that what their instructions are? So what do you guys think is an easy way to do it? Just grab one of them and find its inverse, right? That could be an easy way. But that's not what we like to actually technically do. What we like to do is actually take the composition of the 2 functions. Okay, so for example, what was my regular equation? What was my f of x square root of x minus 3 plus 4? Is that what it was? That was my original one, correct? Okay, what they like to do is to do the composition of these 2 functions. So I'm going to do f of f inverse of x. Okay? Now, if you'll notice, when you do an inverse, aren't you basically doing the inverse operation to undo something to get rid of it to the other side? Like, for example, how did I get rid of this plus 4? I subtracted it, didn't I? How did I get rid of this square root? I squared it, didn't I? How did I get rid of this minus 3? I added it, correct? Where you see the steps? Because I undid every operation that was in here, correct? So when you take the composition of these 2 functions, what will happen is that those operations will undo themselves, and if it comes out to be just plain old x, it proves that these guys are inverses of each other. Okay? Does that make sense? So therefore, I'm going to show you how to do so. So we're going to start with f of f's inverse, which is x minus 4 squared plus 3. So therefore, I am plugging this stuff right here in for that x right there, isn't it? Am I not when I'm going to do this, right? Okay, so here we go. I'm going to say, okay, square root of this stuff. Now once again, what did I always tell you to do? When you insert something, what should you do? Put parentheses around it. So I'm going to put x minus 4 squared plus 3. Put parentheses around it. That's the x, correct? Minus 3. And then we have this plus 4 outside. Does everybody see what I just did there? I inserted the f's inverse back into f's function. Okay? Everybody okay? Okay. Now, do I really need the parentheses that I had up there? No. Why I would do that, just imagine if this guy was like a 2 or something right here. Then would I really need those parentheses? Sure, I'd need to distribute through or something of that sort, correct? But I always insert with parentheses just for that fact of the matter to make sure it's okay. Does that make sense? Okay, so at my stage, I personally do not need these parentheses anymore. So I'm at here. X minus 4 squared plus 3 minus 3 plus 4. Anybody see what happened there? They will reduce out to be 0, right? So now I'm at the square root of x minus 4 squared plus 4. Can you see that? Now what happens? A square root gets rid of a square, doesn't it? So now I'm at x minus 4 plus 4. Do I need those parentheses? So basically that's just x minus 4 plus 4, which is just, see how it comes out just to be x? That proves that those guys are inverses when you do the composition. Okay? Does that make sense to everybody? This 4 out here? Okay, so he's been out here the whole time. Are you okay with that? You see how he's always out there? good. And the reason why he's been out there is because notice, here's the stuff underneath the radical, and we always have a plus 4 out there. You okay with that? Yeah? Okay. Now, that proves that they're inverses. Technically, it really doesn't, but for our cases today, you only have to go one way. Technically, you're supposed to do f of f's inverse, and then now we're going to hurry and quickly do f's inverse of f. Because it shouldn't matter what way you take the composition. Now, there are some functions, okay, when you find its inverse and you take the composition, it'll work one way, but it won't work the other way. And I'm going to show you that in just 1 second, okay? But at the same time, you actually need to do it both ways. But like I just said, for your purposes of your homework, go ahead and show it the one way. Does that make sense? Things that you got to be careful with are things that are raised to a higher power. Things that are raised to a higher power, such as the 4th root, the 2nd, or 4th, 2nd, 6th, or any even root, you're going to have a plus or minus happening, and that's when it affects it. Okay, so here we go. So, once again, could somebody tell me what f's inverse was? I think that would be, might want to write those down. For this fact of the matter, we had f of x, which I believe was the square root of x minus 3 plus 4, right? And f's inverse was x minus 4 squared plus 3. Am I correct in those statements? You okay with me now? Okay, so now we're going to do f's inverse of f of x, okay? Because technically we're supposed to show it, like I just said, both ways. But once again, like I said, you guys can do either one. So, I have f's inverse of f of x, which is the square root of x minus 3 plus 4. Okay? Once again, I'm inserting this stuff right here into that x right there. Am I not? That's the goal. So here we go. Parenthesis, x minus 4 squared, but our x is square root of x minus 3 plus 4. You guys see what I just did there? Good? You okay? And then notice, then what do we have out here? We have that plus 3. Everybody see how I did that? I just inserted this into that x right there. Okay? I just lost you, I think. Where did I lose you? Okay, so first off, are you okay with me inserting what f of x is to here? Okay, so now, here is f's inverse. So therefore, this stuff is replacing that x, so therefore I'm going to replace it with this x. So I have my large parentheses, quantity squared, with my minus 4 right here. So this, all I did was insert this stuff for that x. Yes or no? And then notice we had that plus 3 outside. Did we get that? Okay, this is where it gets a little bit more challenging because it's the fact of the matter, it's larger things, right, than just like what we did on number 1, like a 3x. Like that. Okay? So, what can we do? What do we see right there? Is this plus 4 underneath the square root? So therefore these guys are going to do what? They're gone, aren't they? So now, I am at the square root of x minus 3 squared plus 3. What happens there? The squared and the square root get rid of each other, don't they? So I'm at x minus 3 plus 3, which happens to come out to be, you see how one way it worked and the other way it both worked to get to x, right? That proves that those two are inverses, right? Good. That's going to basically be the homework today. Listening. Down to here. Okay? What does something squared mean? It times itself, right? So therefore, if I do that, that's square root of x minus 3 times the square root of x minus 3, which actually just comes out to be x minus. Because a squared will always undo a square root. Austin. Exactly, because right now you don't know if they're inverses or not, correct? So therefore their question is asking, are these two inverses? Correct? So therefore what would you do? I'm going to show you an example of one of your questions in just a second. But you would just do f of g or g of f. And if it comes out to be x, they're inverses. If it doesn't, they're not inverses. No. I'll show you in just 1 second. Let me just show you once again why. Here is an example, really quickly. Here is f of x equaling x squared. His inverse is really simple. How do we solve for y really quick? What? We just did that. We just switched. How do we solve y? Go ahead, Austin. Okay, did anybody remember when we take a square root what you're supposed to do? What do you do? Plus or minus, right? So therefore, y, or f's inverse of x, is plus or minus root x. Okay? Does everybody see that? That would be its inverse. Yes, no, maybe so. Feel comfortable? Okay. Now I'm going to see if these two are technically truly inverses. Okay? How I do that is I need to do f of f's inverse and f's inverse of f. Okay? Those are the things I need to do to prove it. So I'll do this one first. It will be f of plus or minus square root of x, which comes out to be plus or minus square root of x squared. What happens when something's positive and it's squared? How about something that's negative and squared? Positive, and what happens with a squared and a square root? They just get out, so this is x. So far it looks like they're inverses, right? Is that a true statement? Well, watch when I do this guy. So that's f's inverse of x squared, which would equal plus or minus the square root of x squared. What's the square root of x squared? X. So now I have plus or minus x. Is that just x? That's not. So are those two technically inverses? You see why you always have to do one way and the other way, technically? Okay? That's an example of why. Does that make sense? Okay. Does everybody understand how to check to see if they are inverses? You're just taking the composition of the two functions. That's all you're going to do. So, an example. Let's go off the blue worksheet. Give me any example you want to go off of. 17 I heard? I think 17 would be great. 18 might be. 17. Okay, so what does 17 say we agree to? F of x equals x plus 2, and g of x equals? Alright. Everybody ready? Okay. So, we need to do a composition. It doesn't matter whether it's f of x, f of g of x, or g of f of x. It doesn't matter. You just got to take the composition off, okay? So, I'm going to do f of g of x, which is f of 1 over x plus 1 minus 2. Carlos, you're tired today. Why? Didn't sleep. I had a good life. Mr. Mingleson was in my dream. I ate his Subway the other day. I don't know why I ate his Subway, but I did. No, I already ate my Subway. I was supposed to wait. I don't know. It was just a Subway. guess I was in a film when I was supposed to eat my Subway in the film, and I already ate my Subway. So then I had to get another Subway in at Mr. Mangelson's. I don't know why I was thinking about Mr. Mangelsson. But he was in there, I told him about it. Okay, so the thing is, we're going to put all this stuff right there, right? Is that a correct statement? So here we go. 1 over x. X is going to represent these things right here, correct? 1 over x plus 1 minus 2. That represents our x. Does everybody see that? I'll bring it up. I'm almost there. Plus 2. And then we have our minus 1. Okay? We inserted that stuff in for the plus 2. Everybody there with me? Okay. So, do I really need my parentheses? Is there anything there that I really needed it for? Besides just getting in that habit of doing so. There isn't, so therefore I can drop them. So therefore I'm at 1 over x plus 1 minus 2 plus 2 minus 1. What happens there? Yes, sir. Yep, as Rich said and you said it, the 2's are gone. So now I am at 1 over x plus 1 minus 1. Okay, how many of you guys remember what to do when you have like a number divided by a fraction? What do you do? We times the top by the bottom guy's reciprocal, if you'll remember, right? So notice this would be the same thing as 1 times by the reciprocal of 1/2 would come out to be what? Which is 2. Everybody see that? Isn't that basically the same thing? We have a number divided by a fraction, don't we? Are you there with me? So, with that being the case, I am going to times 1 by this guy's reciprocal, who is x plus 1, right? What's 1 times x plus 1? And then we have this minus 1. X plus 1 minus 1 is, are they inverses? They are. Now I should go back and do it the other way, but like I said today, sufficient enough to just do it for 1. Okay? Does everybody understand that? Technically what I did here, Hogan, is I took this number 1 and I multiplied it by this guy's reciprocal. What is 1 over x plus 1's reciprocal? Huh? Right? You just go this times this over 1, which is the x plus 1. You okay? Any questions? Does everybody understand the ordeal that they're doing today? I'm going to finish up the back side of the blue paper, which you probably already had half of it done, hopefully, right? So you're going to finish up the rest of those 6 problems. And I also have a worksheet over here for extra practice, because I think this is an important thing to know. So, you not only get those 6 problems